Okay, so let's look at a few other missions here. The last time we talked, the Dawn spacecraft was about to reach the largest asteroid, Ceres. And the beauty of this mission is it is powered by an ion engine. So instead of using chemical propulsion, it uses an electrically charged grid and ionizes xenon and spits that out the nozzle. But it's a very, very, very low thrust rocket motor, but it's able to do this over an extended period of time. Since they launched in about, 2007 that Dawn launched, the ion engine has been on for something like 3 years of time during that. And so that allows them to do a lot of very innovative celestial mechanics, if you will. And you'll see that in just a second. So this is the path I think I showed in the end of February, the last time we talked. And we were about right here the end of February. And it was early March when Dawn finally got close enough to Ceres that it was able to be captured in the gravity well of Ceres. And then it's been adjusting its orbit ever since. And so this was taken in mid-February as they were still approaching Ceres. And the interesting thing is that there are a couple areas where they see these really bright spots. Both areas that they've seen this, they're inside craters. And right now, they don't have a clue what that really is. They don't have enough resolution on them to start seeing morphology to see what the structure of them is. But that will be solved fairly soon. So that's the most exciting thing they've seen so far, other than the fact that there's lots of craters, which is what you'd expect. And there seems to be variation in brightness across the surface. And so this is an animation showing how Dawn arrived at Ceres. And so there's the spacecraft, here's Ceres, here's our date. And so it's right about here, I think, is where they're finally captured into orbit. And then since then, they've been adjusting their orbit to get into a much closer polar orbit, where they're orbiting from pole to pole, and that way they are able to cover the entire surface of Ceres as it rotates beneath them. And I think this is going to rotate around in a second, so you can see how interesting this loop-the-loop geometry is. Okay, so March 6th is when they were captured, and this is just a rotation movie on the way in. There's that double bright spots in that crater. And so what they'd been doing for much of the last month is trying to adjust the orbit to where they'd be able to get into this polar orbit. And so this was a view from about, I think, 30,000 kilometers out. So the North Pole is right beneath us here, and you're just able to see just a crescent of Ceres on the illuminated side of the planet. And so here's a view from just about 10 days ago. And here's our two friends, these bright spots, and they still don't have enough resolution to really say what they are. But stay tuned. This is the type of thing that it's only going to get better. They just this last weekend entered into what's called their science orbit. And so they're now in this polar orbit, and then they're going to be getting closer and closer. I think they're something in the neighborhood of 10,000 kilometers above the surface at this point. And over the course of the rest of this year, they'll be dropping that to something like 500 kilometers above the surface. And this is just a still image showing slightly better resolution. And here's our two bright spots again. So let's move farther out in the solar system. The New Horizons mission is on its way to doing its Pluto flyby in mid-July. And just today they released their latest images. Still not much to write home about, but they're better than anything we've seen before. Because from the ground, Pluto is just a bright spot. Even from the Hubble telescope, you only get a few pixels across. And so let's talk about this mission for a few minutes. So the spacecraft was launched in January of 2006. It's been on its way ever since. So coming up on 9.5 years when it finally does its flyby. It flew past Jupiter and Saturn in the course of its traverse of the solar system, and it finally reaches Pluto in July, and then it will be traveling out into the Kuiper belt over the next 4 or 5 years, and hopefully seeing some other icy bodies even farther away than Pluto. And so this was an image released earlier this month. It's the first color image of Pluto and Charon, its largest moon. And you can see that Pluto isn't white or black, it's sort of pink. And that's one of the interesting things, is figuring out what's causing that type of coloration to the surface. And so I wanted to show you an example that they talked about today of how they actually improve the resolution of the images. So first of all, you can see that actually if everything was perfectly in focus, Pluto would just be 1 pixel at this point, but it's actually smeared a little bit because of the optics aren't perfect. And so what they do is take multiple images, they combine them, and then it's called subsampling, where if you had, say, 4 by 4, you make that 16 by 16. And it doesn't really improve your resolution, but it gives you more pixels to play with. And then they pass it through a computer technique called deconvolution. This was something that became very heavily used in the early days of the Hubble Space Telescope when it had its focus problems. And it allows you to sort of artificially sharpen the image because you know very precisely what the optics are doing to the image. And so it lets you sort of get resolution that isn't obvious here. And so what you can see on this image then is that you have gradations in the brightness of the surface. And that really is telling us that there's probably some variability across the surface of Pluto. It could be ices on the surface, it could be other material that's darker and covering up the ices, and we will certainly know over the course of the next couple months. And so this is just an example, again, of deconvolution. So this was an image taken at Jupiter of the large moon Ganymede by the LORRI camera on board New Horizons. And so this is what you'd have just with the raw image. And then when you pass it through the deconvolution technique, you can see that there's a fairly substantial increase in the sharpness. And so it actually does work. So here's an image that they just released today showing the geometry of their observations. And so what we're seeing is this is the North Pole of Pluto. The South Pole, we're sort of seeing it sideways. And here's Charon orbiting. Here's a close-up of Pluto. And you shouldn't take this to mean that Pluto is irregularly shaped. Pluto is certainly a sphere. It's large enough that it will collapse into a sphere. But what this says is that it's just we're seeing the brightest stuff on the surface, and then any darker stuff that's on the edges sort of gets lost by doing this type of process. And this actually is a more interesting view, I think. It's showing the real motion of these. The previous one had Pluto fixed in the center, but you can see Pluto is sort of wobbling back and forth, and that's because it's almost a dual planet system. Charon is large enough compared to Pluto that they mutually orbit around the center of mass of the system. And so Pluto is wobbling in and out slightly, and Charon is wobbling a lot more than that. So that's what was released today, and they will be starting to do daily imaging leading up through about the end of May. So we should be seeing a lot more data coming out. It's still 110 million kilometers away from Pluto, so it's approaching fairly rapidly. We're just a little under, I think, 3 months from the closest approach. So come June is when they expect to actually start being able to see some features on the surface, and so it's going to be an exciting couple of months.